Hello people, I am making a quick video to help you with the most recent lab, the virtual lab that I sent. So from Remind, I'm looking at my desktop here of course, but from Remind, you need to go to the lab guide. So link for lab guide, it's the Google Doc. You click on it and you do not have edit access. Right? So you don't have edit access, don't request edit access. We need to leave this one the way it is so everybody sees the same thing. But you go over here to File and either make a copy or download, say as a Word document, and then you can edit that. I'm going to make a copy and copy of CP. I'm just going to save it in my drive. Okay, so now I've saved that, or as soon as it catches up to me, I have now saved this, and now I can edit this. Okay, the next thing I'm going to do is now that I'm going to close out this one so I don't get mixed up, and I'm going to go back to Remind, or actually you can just do it from here too. I put the links right here. You can click on this, and it takes you to the simulation you'll be using to answer the questions. So the first thing we're going to do is I would just go click on I think intro or lab. Let's see. Intro's fine as long as I have a stopwatch. Yeah, we're good. Okay. Let's read this. Answer bold and numbered questions. You can drag the stopwatch and the ruler out into the workspace. Okay. Place a 100-gram mass on the spring and turn the damping to 0. Place a 100-gram mass on the spring. I think the damping already is 0. Right, so it'll just keep going now. If you have damping turned up, it'll come to a stop. That would be more realistic. But this will just keep going. Okay, so there it goes. It's bouncing up and down. Let's see what am I after here. Okay, get the mass vibrating up and down with the spring at its default stiffness value. That's just you can change the stiffness of the spring right here. Right, so it's at its default value. 3 clicks over, and it's bouncing up and down. And we have to answer this question. What are the period and the frequency of the vibrating mass? Okay, so I go to here and I pull up my stopwatch, and what I do is I watch it. I like to put a line here that I can move around. Well, that was at a good position actually. So here we go. It's going up to that line every time it vibrates, and I'm going to time it. That's all. And each time it returns to the same position, that's one full cycle. So from here to here is its period. But that would be really tough to time. Here to here, about 0.77 seconds. And I wouldn't use that value though. I'd reset and I would count 10 times. Right? So let's do that because you're going to get a better value. So I'm going to start at the top and press the stopwatch. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, it's just slightly different. I got it about 8.2 seconds for 10 vibrations. Okay, I'm going to go write that down just to keep my head clear here. 8.2, so 10 vibrations equals 8.2 seconds. Well, great. All I have to do now is, it says, what is the period? So T is defined as period. And period is defined as the amount, how long it takes. Period is how long it takes. The amount of time it takes to complete one full cycle. Right? The amount of times it takes to complete one full cycle, that's the period. Okay. Well, it did 10 cycles in 8.2 seconds. So in this case, all I do is if I calculate the number of seconds per cycle, that's going to be the period. So the period is the number of seconds per cycle. Well, there were 8.2 seconds. It took 8.2 seconds to do 10 full vibrations, or 10 cycles. Okay, and 8.2 divided by 10 is 0.82 seconds. That's the period. That's how long it took. Right? So I've just done the first one for you. I should have maybe used a different mask or something. Um, but I also ask you, I say in the first question, what is the period and what is the frequency? Well, let's go ahead and do this and change this color to something else. And I'm going to go down here. And so I just spoke about periodicity. Well, now I'm going to speak about not period, but frequency. So again, it did 10 vibrations. It did 10 vibrations, or 10, I'm calling it cycles. Yeah, I'm using those terms interchangeably, and they are 10 cycles took about 8.2 seconds. Okay, well, what's the frequency? So let's define lowercase f as frequency. And frequency is how often, so this is just in English, how often something happens. How often something occurs. That's frequency, right? What is the frequency with which I brush my teeth? Oh, twice or 3 times a day. What is the frequency that I go swimming in the ocean? Well, I guess that depends on the time of year. But this time of year, it's once per week or whatever. The frequency is how many cycles, in this case, how many cycles happen every second, right? So the frequency here is going to be defined in terms of not seconds per cycle. That's how long it takes, the number of seconds for one cycle. That's the period. But instead, it's cycles per second. That's frequency. How many times it happens per second. Okay, so all I do is I do that, here's my information right here. Here's my critical information right here. It's so critical, I think I'll mark it in red, right? So there's my critical information, and from this information, from simply timing 10 bounces, I can get the frequency by dividing the number of cycles per second. Well, 10 cycles divided by 8.2 seconds. So 10 cycles 10 cycles in 8.2 seconds, so whatever this is, it's just over 1, right? Let's pull out the calculator. I don't use this calculator too often. Here, there it is right there, calculator. 10 divided by 8.2. 10 divided by 8.2 is 1.22. 1.22. Please don't write all those numbers. That's crazy talk. 1.22. Or even just 1.2, right? How often does this thing cycle? It cycles 1.2 times cycles per second. It cycles 1.2 times every second. Well, that makes sense. It does 10 cycles in 8.2 seconds, so it's doing just more than 1 cycle per second, right? And the number is 1.2 cycles per second. That's the frequency. We have a name for this unit. Cycles per second are known as hertz. So F is 1.2 Hz for hertz. And that means 1.2 times every second. So that's how you do this virtual lab. You just go through it, and then I say stuff like this. So I would just write in here. I would say I would edit this, and I would say the period equals 0.82 seconds, and I'd say the frequency, what was that, 1.2, I think, 1.2 hertz. Boom. Okay, now change the stiffness to large. Okay, I'm going to go over here now. Maybe I'll reset everything just to make sure everything's, recalculated. We just made the spring stiffer and harder to stretch. Put the 100-gram mass on it, pull it out, and now let's try it. Let's get that movable line back in there. It's not in a good position. Put it somewhere where I can easily see it. About there. Let's go a little bit higher than that, maybe. Pretty close, pretty close. So I pull up my timer, and I just do the same thing again. Let's see. There's no way I can, now it's going faster. There's no way I could time it for 1 cycle, right, and be accurate. Ready? Start. stop, 0.5. Yeah. So you have to do it for 10 cycles. You get a better number. Ready, start. 1, 2, 3, 4, 5, 6. I stopped it early because I don't want to give you this answer too. But you do the same exact thing I just did. And you do the same exact calculations I just did here. You write down your critical information, right, which is the number of cycles per second, 10 cycles in 8.2 seconds. From that, if you divide seconds by cycle, you get the period. And if you divide cycles by seconds, you get the frequency. Okay, so let's see here. That's how this first part goes. Change the spring stiffness. Now do the same thing again. When the spring stiffness goes up, how does that affect the period and the frequency? Well, so that just means, how does that affect the period? Well, look how fast it's going. It takes less time. So when the spring stiffness goes up, the period goes down. And the number of times it happens a second is higher now. So the frequency is up and the period is down. So you want to say that just in clear language right there. Then it says hit the reset button in the lower corner. Boom, I hit it. And it says find the period of 3 different masses on the spring. Make a general statement regarding, when mass goes up, frequency goes up. Or when mass goes up, frequency goes down. Or whatever you find, just make a general statement like that. I'm looking for qualitative statements, such as mass has no effect on period, or when mass goes up, period goes up, etc. So with this one, we're not messing with the spring. Now, we have numbers for the 100 gram, right? I don't know, let's put this guy on there. Now measure that. The mass is higher. What's up with the period? Does it take longer or shorter? What's up with the frequency? Is it happening more quickly or less, more times per second or fewer times per second? How about a little 50 gram mass? What does that do compared to the first 100 gram mass? Right? So, I can just evaluate these things one at a time and you're off and running, okay? And the second one is pendulum motion. And it's very, very similar. It's really the same exact stuff, except it's a pendulum, right? So here's a simulated pendulum. I think we can just use the intro here. And again, I say, okay, get it swinging. And, stopwatch, yeah. So click stopwatch over here. There it is. And I can, so from here to here, that's one full cycle. So let's see, it's about, well, I'll tell you what I'm going to go. Ready? I'm going to start, stop. It's in the range of 1.5 or 2 seconds. I wasn't very careful. And again, I would do it for 10 vibrations to get a good number, right? And then it says it has you do things like change the length. Change the length and make a general statement. Oh, it takes longer now. Oh, it takes shorter now. And stuff like that. Change the mass to see what happens. The mass is getting smaller, the mass is getting bigger. Just evaluate it for the mass and say, when the mass gets bigger, that takes longer. Or when the mass gets bigger, it takes less time. Or maybe the mass has no effect at all. You are to find that out. You are to find that out by just timing this thing and seeing how it goes and just answering these questions. Does mass have an effect on the period or the frequency? Well, you change the mass. Did the number stay the same as the original? Okay. Does amplitude? That means how far it swings, right? So amplitude is a word that means here. So let me reset this thing. Here's a small amplitude swing. It's not going very far out of its rest position. That's a small amplitude swing. Okay. This is a larger amplitude swing, right? It's going farther from its rest position. That's a larger amplitude swing. Now, my suggestion to you, for reasons we don't really have to go into, pendulums start to get weird when you bring them way out here. So I don't know if I would do that as it's large. You're going to get interesting and a little bit weird results if you do it way out there. When you're comparing small swings to bigger swings, do stuff like this. Call that a small swing. And maybe just, if that's 10 degrees right there, I think it is 10, 20, 30, 40. Yeah, that seems about right. Oh, it even says it right there. Sorry. Yeah, there's 10 degrees. So maybe try a 10-degree swing and get the period. And then do the same thing, but do a 20-degree swing. I wouldn't go much beyond 20 degrees. you're going to start to get weird results. But just compare, that's the amplitude, small amplitude, large amplitude. Does it take longer or shorter, right? So that's all. That's all you're doing here. You don't have to really do too much serious heavy lifting here. You just have to time the pendulum. And does the length have an effect? So change the length and see if it takes longer or shorter. That's it. That's it. That's all you have to do. Okay, I hope that helps. Give me a shout if you still have questions, and we'll take it from there. Alrighty. Have a good day. Bye.